takes a while to switch, actually, because there's a lot to be done. Right, so good morning, everybody. So my name is Joram Barrez. I'm Flowable core developer, and with me I've got Tijs Rademakers, the Flowable project lead. And in this first presentation, we're going to shortly discuss, the current state of things, the last releases, our vision, and stuff like that. I guess that most of the people that have found their way up here know what Flowable is, but just to make sure, it's Flowable is an open source project, Apache2 license, we're a fork from Activity. We're all about the business process engines, about case engines, the DMN rules engines. We have an active community, and more about that later in the slide deck. Our core development is funded by Flowable, the company, same name. Our last release was 6.4.0, and there's a few pointers there, and more specifically, if you follow that pointer, github.com/Flowable, you come onto this page, and what you see here is the signs of a healthy, vibrant open source project. I mean, we're very close to the 10,000 commit. I'm really going to try to get that 10,000 commit myself, and I'm sure others will do that too. You see lots of contributors, a healthy amount of issues, pull requests and stuff like that. I made some pretty graphs with stuff from GitHub. The GitHub stars now, GitHub stars on itself don't say a lot. I mean, we could put something with JavaScript at the end and suddenly we'd have 10,000 in one day. The point is that the trend line is very important. You can see that since the inception, there's a positive, always upwards trend in GitHub stars. That means that people, they find us, they use us, and they like us, right? That's why you can see this. You can see the same thing on the forum. You see since the inception that the forum traffic just has steadily risen, and it's, every day there's lots of posts, lots of people asking questions, which is a healthy sign for an open source project. Some other interesting numbers, and if you look at the last 6 months, we did 2 releases. We had 236 PRs, pull requests, and we had 29 contributors. So even though I said in the first slide that we're funded by Flowable company, this means that there are a lot of people outside of that core group that are actually contributing externally to Flowable, which is really great. But don't take our word from it. If you, for example, go to OpenHub, OpenHub is a system from Blackbook Software. You know them, but basically they take codebase and analyze them. And for example, one of the things they say about us is that it's a mature and well-established codebase. Well, we kind of knew that, of course. But also that we're a very large and active development team. I don't know if you can read it, it's quite small probably, but we're in the top 2% of sizes of project teams on GitHub, which is pretty cool if you ask me. And, of course, very important, there is a stable year-on-year development activity. We're continuing on the same pace, we're not dropping off, we're keeping that same pace that we always had. And people that have used us, they probably know about this, that our goals are really about these things when we talk about the engines. First of all, performance. We want to have the fastest engine possible, and there's a bit of talk about that later on today too. Performance on itself is, of course, is one thing, but also scalability. You can be the fastest, but not if you can't scale, it doesn't mean anything, right? So if you want to deploy it on a bigger scale, it's also quite important. And we did quite a bit of work the last year to make that happen. Again, let's talk about that later in the talks. One of the core goals when we started with Flowable has always been that it should be easily integratable into any project, into any Java technology, anything you want to do with it should be possible. Embeddability is really key for us there. That means that we really go great lengths to make sure that it's easy to just add a dependency and run with it. Developer power, this means whenever we do something, we make sure that there's the extension points, playability points, that you can override it. I mean, we have use cases in our mind, but there's always when you give something in the open source, you see that people take it and do something completely different with it that you did not expect, which is great, of course. And that's why whenever we design, whenever we architect, it's really always extensible and adaptable. Adaptive and dynamic, and I'm not going to talk too much about it, because there's a specific talk about that later today. One of the things we did is really, the core architecture of Flowable is made to be able to adapt easily. We're running instances, cases, and whatever, to dynamically changing, but I'm not going to tell too much, because then I'm going to steal his thunder, so he's going to tell more about it later today. One of the things is also that we don't take opinions on how you want to build it, how you want to ship it. I mean, everybody has their own kind of way of distributing their own project, their own application. And we don't take an opinion. We give some defaults out of the box, but we don't take an opinion. And Flowable is easy to use in any of these environments. It's really one of the goals that we try to take whatever we do. And if you look at the Flowable engines from a high-level point of view, then if you come in from the top, there's really 3 things, right? You have the models. Processes, of course, are BPMN processes, CMN cases, DMN rules are of course the obvious one, but we've got a few more, like for example apps. Apps is a pretty new kind of thing we have, the app engine, which allows you, for example, to bundle these models together and kind of deploy them as one package across different systems. The engines, of course, they take these models, they make them runnable. If you, for example, have a process model, you can deploy it on the engine, you can start a process in the engine, and things like that. You can deploy it standalone. For example, you can use a REST API, you can embed it, or you can write your own REST API on top of it, whatever you want. Very important, as I said in the previous slide, is that we always try to take as little resources as possible. Resources meaning CPU, memory, we always try to be at minimum level there. And last but not least, of course, is the APIs that you interact with. We're very proud of the APIs that have been stable over the years. If you look at a couple of years ago, you look at the APIs, they're still the same. I mean, or we did change, of course, we added new features, but APIs, the concepts have remained pretty much the same over all these years, which is sometimes hard to do because you want to break stuff, and it's more work not to break stuff. And with that being said, I'll leave now to Tijs, because now it gets really hard.
You have a fast pace, that's really cool. So sorry for my voice, it's a bit wasted due to a cold, but hopefully I will manage. So this is one of the more important slides you will see today, because this shows most of the work we have been doing in the last 2 years. Which is really, we started with a big BPMN engine module, which basically contained everything. It contained identity management, it contained form logic, it contained content logic. But when we started with adding a CMN engine and also a DMN engine to the Flowable platform, it was really obvious that we needed to split up all these things into smaller pieces. Because a variable service, for example, you want to use that from the DMN engine, you want to use that from the CMN engine, but also from BPMN. But even maybe in a standalone way as well, that you can store a variable with a reference to some entity, maybe living outside of Flowable. So we put in really a lot of effort to break up all these smaller pieces and create new modules with all these things. So all the ones that are shown in yellow, we put a lot of effort in there to create a variable service, create a task service, and have a really convenient interface into all these different modules. And I think one of the main things we took in consideration there while doing it is that we didn't want to break stuff, like Joram was already saying a bit earlier. So we wanted to make sure that if you would upgrade from 6.0 to 6.1 or 6.1 to 6.2, that you didn't have to do much stuff, right? Everything would just migrate automatically, basically. So that's why you will see also a mixture between, for example, liquid-based migrations for updating the database and still the manual database scripts that we always had with the BPMN engine. So we couldn't start over with adding a liquid-based database script for the task service, for example, because that would break backwards compatibility. So we took all that kind of stuff in consideration and focused really on backwards compatibility as much as possible. So another important thing that we added, like Joram was saying, the app engine. So the app engine, it's not doing that much at the moment, but what its main job is that it's managing all the connections to the models in all the engines that are deployed together. So if you deploy one package, it contains DMN models, contains forms, contains BPMN, contains CMN, then the app has a reference to all the models that are deployed together, so you know exactly this version of this form was deployed together with this version of the process. And that's important if you want to keep a package of artifacts together, like if you have an address form or something, and you deploy that together with the specific version of the BPMN process, that when you start a task, the address change task, that it always has the correct reference to the form. And it does that via the app engine because all the model versioning is known from the app engine level. Another big thing, a really big thing, and I think we spent maybe the same amount of time as splitting up all these services, is the CMMN engine. And with the CMMN engine, we looked at the spec and we really started thinking over what is the best persistence model for the CMMN engine. So if you look at, for example, at how Kamuna did the implementation of the CMMN engine, they dumped it basically on top of the BPMN persistence model. But to our opinion, CMMN is something really, really different from BPMN, and it also needs a very different persistence model, and it needs different entities, it needs a different API for you to work with. So we really started with creating a fully new engine. It has its own tables, and nothing is shared between BPMN and CMMN on that level, and it has its own API and lifecycle. And you can use the CMMN engine standalone. You can use the BPMN engine standalone, but they also work nicely together in an easy way. But still, they also share the same task service, they share the same variable service. So if you query on tasks, for example, if you want to get back all tasks, it doesn't matter if it's BPMN or CMMN, you can get that because it's stored in the same database table. But if you only want to get the CMMN tasks, that's also possible, of course. So yeah, that's another piece that where we put a lot of effort in. Also the Spring Boot starters. So we took quite a bit of effort, mostly done by Philip, who will also present a talk about that in the afternoon. He did a lot of work to create nice and clean Spring Boot starters, so it's really easy to start with a starter with the BPMN engine or the CMMN engine or all together. So that's something we added as well. And then on an integration level, I think nothing really changed there. That's something we always had. Camel integration, Spring integration, OCI integration, LDAP, and that's just something we want to extend more and more. So let's have a look at a couple of the highlights of the latest releases. So a lot of effort has been put into running the CMMN engine, BPMN engine, DMN engine standalone, but also that they work really nicely together. So this diagram shows that now it's possible to start a process, for example, from a CMMN model. So we have all the flexibility, eventing, logic on CMMN level, and then the structured child process stuff that's happening in the BPMN engine as an example. And you can use the DMN engine for both CMMN and BPMN, of course. But you can also go back from BPMN to CMMN by using a CMMN task, by starting a case from BPMN. And that's something, that last bit we don't have in the current version, but it's coming in the next version. So then it really ties into the engines altogether.
Maybe to mention here is that when you call out from, that's kind of the big slide that Tijs was showing before, when you call out from CMMN to BPMN to DMN, wherever you go, the reason why we had to restructure all these services, or separate them all as a shared kind of service, is that you, of course, when you call out from CMMN to BPMN and you're having a transaction, you want to make sure that they're part of the same transaction. You want, if something happens here and stuff rolls back, that is also rolls back here, right? And we could have, hacked that in some way, but we decided to properly have these shared services that make sure that nothing goes wrong. If you look into the low-level code, you will actually see that if you run them together, so if you run CMMN and the process together, that they actually start registering stuff on the lowest kind of SQL session that we have on the lowest level, and they start interacting with each other. So actually the process can see stuff from the case if you wanted to do and stuff like that. So it's quite powerful, and the slide doesn't really show that, but that was where we spent lots of effort to make sure that that is actually consistent with what we've always been doing. And just sorry to interrupt you.
Thank you.
I spend lots of time personally on that.
I know.
Excuse me, will you share the slides?
Yeah.
Yeah, thank you. I think Joram was already referring to this in an earlier slide. So a lot of effort has been put into the performance optimization of the engines. So there's a lot of caching going on. There's a lot of optimization in, let's have an example where you start a CMMN case and then do start also a process as part of that CMMN case. And a lot of entities are created, and maybe even the process is going from start to end immediately. So it already finishes in the same transaction. Then we do a lot of optimization that when we really flush to the database, we look at, is this process instance execution, for example, already deleted? Then we don't insert it, of course, and we don't do updates on it. So everything is cleaned before flushing it to the database. There's also a lot of caching going on. If we fetch an execution or a process instance by ID, then it's automatically stored in the cache. So if it's retrieved again, it's retrieved from the cache, all that kind of stuff. And Joram did a couple of blog posts about that to show the performance of the 6.3.0 version, and also comparing that with earlier versions. And as you can see in this slide, we did we had quite a performance boost from definitely from 5.21 to 6.3, but also from 6.1 to 6.3.
And also, when you read that blog, it also goes into the fact that you could make one specific call very fast, but it doesn't mean if you do thousands of them in the same second that all of them are fast, because you have a lot of contention between those things. So a lot of the stuff that we've been doing, and I'll talk about that later too, is to make sure that when you have a lot of contention, it still is fast, because it's easy to really optimize that one thing, but if you then start running it on lots of servers, it isn't. And that's really where, if you haven't read it yet, that's really what this blog talks about. I'm quite proud of the results there.
Another important thing, and we also mentioned that in one of the next slides, is asynchronous history. So there's also a lot of performance optimization that you can get by using asynchronous history, because by default, if you have history turned on, the historic information is stored in the same transaction as the runtime data. So it all slows down your persistence at the end of the transaction. And we have asynchronous history to basically overcome that issue and to give you a bit more flexibility on that level.
Can you explain a little bit about what the asynchronous history is doing?
Yeah, slide, 2 slides from now, I think it was a slide.
That's one comment. That's it's the next slide actually. So if we look at integration, so one of the really most important things is that we focus on keeping the framework lightweight and embeddable. And if you now start using the BQMN engine, it might not seem like that anymore, because you need quite a number of dependencies, like you need the variable service, you need the task service and all that. So you get quite a number of jar files as part of your project if you add the BQMN engine as a dependency. But still, all these different modules are really basic and lightweight. So you might have 20 dependencies, but it's still altogether a really lightweight framework. And that's something we try and keep as much as possible. Another thing is Spring Boot. So Philip will have a talk later today to go more in depth about Spring Boot and also show an example application and how you can create that in an easy way. But the important thing to notice is that after Spring Boot 2 was released, we did also a release using Spring Boot 2 quite soon after, and we try to follow up with that on a regular basis so that we keep up with the pace of the Spring Boot framework there. Also Spring 5. So we have Spring 5 support. If you are still using Spring 4, that's also fine. So we don't depend on Spring 5 specific features on an engine level. But we do support Spring 5 out of the box. JDK compatibility, so that's an interesting topic nowadays. Now with all the releases that are coming in a year, for a framework like Flowable, it's quite a difficult thing to adjust to, because previously we just need to be compatible with JDK 8 or JDK 9, whatever, and we could, that was fine for multiple years. But now suddenly we have to be compatible with 10, 11, 12, 13, 14 and going, which is quite interesting. But I think we spent quite a bit of time to look into how we can make that work. And I think Spring Boot, JDK 11 support is something we are really close to. So it needs just a little bit more testing, and then I think we are quite good there. And I think that's the major effort that we had to go through. Then after this, supporting JDK 12 and ongoing, I think it will be a bit easier. But it's definitely a challenge for a framework like Flowable. Also on our QA system, had to have all these Java versions being tested. It's not an easy job, but we use Travis a lot from when you commit something to GitHub. Then Travis builds are being executed automatically, and that does a lot of the heavy lifting to test against all different kinds of JDKs for us. So I think we can be quite happy with what Travis is providing us there. Yeah, and actually also a really interesting thing that Joram will continue talking with after this presentation is the MongoDB persistence. And it's not only that we now can support quite a number of cases on MongoDB itself, but I think the main thing is that it was actually quite easy to plug in the persistence logic for MongoDB. So if you would like to do the same thing on another NoSQL database or yeah, I think maybe NoSQL database, it's not that hard to do. Definitely not when looking at the MongoDB implementation. You can copy quite a bit of that logic, I think. So the most important thing I think is that even on the persistency level, it's quite easy to plug in your own logic there. And yeah, we were quite happy with the results we got from doing that with MongoDB. So Joram will talk about that in a few minutes. So about asynchronous history, this slide shows an example of using asynchronous history together with a message queue, but that's an optional thing. So you don't have to use it with a message queue. You can, but you could also just use the asynchronous history listeners and don't use a message queue. So the important thing is that if you have a transaction in the engine, let's say the bcommand engine, and there's a start event and a user task when you start that process instance. So the first wait state is that user task, and then the transaction stops. If you don't use asynchronous history, then we insert all the executions, we insert the variables, we insert the user task in the task table. But we also do that for the historic table. So we also insert a historic task instance, historic variable instances, historic activity instances, so quite a bit of inserts happening. If you use asynchronous history, we don't do the historic insert, and instead we create something we call asynchronous history jobs, which also have their own tables. So they don't, and we don't put these jobs in the same job tables as the asynchronous tasks, for example, asynchronous service tasks. They have their own historic job tables. So all the data that we would typically store in the historic tables, we now store as part of this historic jobs, and the data is stored as JSON blobs, basically.
And it turns out that that is actually way more performant. I mean, it's counterintuitive if you think about it, because you might think, okay, tell that JSON sorts of data, you put it in a table. Well, it turns out that we did some benchmark. That's also the second blog that was linked. Turns out that this is way faster on any database that we support than actually inserting it into different tables. You actually are, you're actually replacing the work now, you're replacing it with work later, of course. But it turns out that the transaction for the user, so when the user clicks a button, for example, user task in a form, is actually way faster, gets it back, and that's what you want, right? We also played with, maybe you mentioned, but I'm going to steal it anyway. We also played with the idea. We also have an article that instead of having put it into the database, so instead of having this asynchronous history job that Tijs was talking about, to actually have JTA, for example, and put it on the queue within the transaction, because it's important that you don't want to lose it. If you send your history to the queues go down, then you lost your history. You don't want that to happen. So that's why we insert it into the same transaction. But if you use JTA, for example, then you could get away with that. You say, well, we don't insert it, so it's going to be faster. Well, no. As it turns out, it's way slower to actually do that. So it's actually way faster. Again, it's contrary but I was thinking, at least at the time, is that it's actually just fast to append it to this table, and that's it, and then process it later. And that's really what asynchronous history is all about. Sorry.
So when it's stored as part of these history jobs, then there's a listener system that you can register on the engine configuration, and you can register your own listeners there, and they get invoked when the history jobs are fetched from the database, and you can then process that historic data as you like, basically. So you can still insert it into the relational tables, of course. You could push it to Elasticsearch. You could push it to MongoDB or whatever, right? So this gives you a lot of flexibility on what you want to do with your historic data. And one of the things we do, for example, in our Flowable platform implementation as our commercial offering, is that we push this data to Elasticsearch. So we do a lot of, we can do a lot of analytics, a lot of search capabilities on Elasticsearch there. But all the infrastructure is there as part of the Flowable open source project. We use that in the Flowable platform ourselves as well, without any changes or something. And like Joram was saying, instead of using the listeners directly to get the data from the historic jobs, you can also use it together with the message queue. So when the historic job is created, we push something on the message queue, and then you can have a pool of message listeners taking care of that this historic job notification. So then you can fetch the historic job from the table and process it. And actually, it also turned out in the benchmarks in the performance testing that when you would use the message queue, instead of going and fetch all the historic jobs with a job executor from the database tables, that using that message queue approach is a lot faster. Also because you can scale up the pool size of your listeners quite easily on that message queue. So that's an interesting alternative from using the historic job executor. So I think this is one of the major features we added in one of the latest releases. Yeah.
What's the typical time span between the actual inserts on the runtime tables until you finally get the listeners to execute for the historic job?
So by default, it's really fast, because what actually happens is the historic job is inserted, but we also notify internally that the job was inserted, so it's actually processed almost immediately. It's still done asynchronously, but it's done almost instantly. So by default, the latency is really minimal there. If for some reason the pool of listeners is already full, everything is busy, then it will take a bit longer, because then it will fetch the historic job with the pool interval, the pool interval, the required time of that executor. So if you set that to 1 second, then it will have a maximum delay of 1 second, for example. So yeah, but in normal cases, it's almost no latency because it's notified internally. Yeah. Another thing we did recently is that we are adding more support to do dynamic changes to a process instance. So we added a possibility to move the state from a running process instance to any other state defined in that process definition. So you can go back, you can go forward, and that's actually what we are using in the process instance migration feature that we are adding, and I'll talk about that later today in more detail. But also, for example, when you have a multi-instance construct, like a multi-instance subprocess, we allow you to add a new instance to that multi-instance execution, so that you can dynamically can add a new execution there, or you can remove one. So we are adding more and more dynamic capabilities there to basically give more flexibility from the static nature of BPMN. Because by default BPMN, we need to draw sequence flows to everything to make it move between the states. But with this dynamic behavior, you have the opportunity to and not follow the pattern defined in the process definition, but you can basically leap in your process definition. And the important thing to notice here is that how we can do this is basically because of the changes we did with the V6 architecture. And that's what we are showing in this slide, is that when we moved from the V5 version to V6, it's always a bit arbitrary when you choose to update the major version of your project, of course. We could release a 7 version next month, for example, of course. But moving from V5 to V6 is really a major change in Flowable. So we did actually a full refactoring of the internal engine in the V6 architecture. And later on today we will show a couple of examples of what really has been changed and how that compares to the V5 version really. But this already gives a couple of points there. And the major point is that with the V5 engine there were a lot of optimizations done, and also there was a thing called the BVM, the Process Virtual Machine. And actually everything was mapped from BPMN to that BVM. So what we were executing in V5 was not BPMN, we were executing the Process Virtual Machine, which was basically a kind of state machine implementation. In V6, we are executing the processes really on BPMN level, so there's no layer in between anymore. It's directly done on the BPMN model, which makes the whole logic, if you really go in depth and look, for example, at the call activity behavior or look at the multi-instance behavior, you can basically follow the pattern if you know BPMN. So it's really, yeah, there's nothing in between anymore. And what that really helps with is that when you are in a specific state in a process instance, we can really predict already up front which executions will be there in the database, which values they will have. So we know now when you do process instance migration or you want to move from one state to the other, we can really break down the current execution tree, but also build it up again. And that was really hard to do with the V5 engine, because yeah, if you just have to look at the database on how the executions were stored there, and it was quite a mess sometimes, definitely. When you use inclusive gateways, multi-instance, parallel gateways, sub-processes even, yeah, it was really difficult to understand why it built up that execution tree. And that's what we did in the V6 architecture to really clean that up. I think Joram will now continue with the implementation, unless there's questions. But we are running a bit out of time.
Already.
Yeah.
That's why I was doing so fast in the beginning.
Yeah, I slowed it down a bit. Are there any questions?
I've got plenty of breaks anyway, so.
Yeah.
It's regarding the dynamic state change. So is it possible to move from a user task or a service task to something which is inside a multi-instance?
Inside a multi-instance, it's so you can move to the multi-instance construct, but inside a multi-instance, it's a bit more difficult because if that's a parallel multi-instance, for example, how do you do that? What is actually what should be created for that parallel multi-instance? So technically we could do it, but it's also how would that actually then look like? What are you trying to do there?
So I was using like I think 6.2.0,
Yeah.
and I think I also tried to move from a user task to a multi-instance.
Yeah.
So I think that was also not doing well. I mean, from user task to the multi-instance
Okay.
construct.
Yeah, so we recently, I think with 6.4, we added quite a bit of changes to that logic. So indeed with 6.2 that was not fully supported yet, but now with 6.4.0, but definitely also with the upcoming 6.4.1, it's a lot better supported. So then that should work without any issues.
If the multi-instance is a user task, then that would work.
So forwards as well as backwards.
Yeah.
Where
Yeah.
Yeah.
Yeah, doesn't matter. Yeah, but I'll show that later this afternoon in more detail how it really works.
I'm gonna set up my next presentation.
Yeah. Any other questions at the moment? Okay. Thanks a lot.